12,000 stocks, one Python script, 60 seconds. That's every publicly traded company in the US market, filtered by market cap and trend direction, before you've had your first cup of coffee. Most traders spend their morning checking the same 50 stocks they always check. By the time they're done, they've missed half the setups worth looking at. This script fixes that. By the end of this video, you'll have a working stock scanner built on real market data, not a screener tool someone else built. Your own Python code, pulling live data from a market data API, filtering 12,000 stocks down to a focus list every single morning. Here's the problem we're solving. The US stock market has over 12,000 publicly traded securities. If you spend 10 seconds looking at each one, just a quick glance, that's 33 hours of work. Nobody does 33 hours of screening before the open. So most people screen a tiny subset, the same stocks they always look at, and they build a blind spot for everything outside that list. The fix isn't to look at more stocks manually. The fix is to let code do the broad screening, so you only have to look at what actually matters. That's what a scanner does. It narrows the field before you ever open a chart. For this scanner, we're going to filter on two criteria: market cap range. We're targeting mid-cap stocks, $1 billion to $10 billion, large enough to be liquid and institutionally traded, small enough to still move, price above the 200-day moving average. Stocks trading below their 200-day are in structural downtrends. We covered this in the regime episode. We don't want to fight the long-term trend. We only want stocks where the trend is intact. Those two filters, applied across all 12,000 tickers, leave us with a manageable list every morning. Before we write the scanner, let's get your environment set up. Python is a free programming language. Go to python.org and click the big download button. Run the installer. And on Windows, make sure to check Add Python to Path before you click install. For writing code, download VS Code from code.visualstudio.com. It's also free and it works on Windows and Mac. Once both are installed, open VS Code and press Ctrl backtick to open a terminal inside it. Then run pip install request. That is the one library this scanner needs. Create a new file called scanner.py and you are ready to build. We're going to use polygon.io. It's a market data API with free and paid tiers. The free tier gives you delayed data, which is enough to learn on. The paid tiers unlock real-time data and more endpoints. We need three things from Polygon. The grouped daily endpoint. This returns price data, open, high, low, close, volume, for every single stock that traded on a given day. One API call, not 12,000. The reference ticker's endpoint. This lets us query stocks by market cap. We give it a minimum and maximum, and it returns every ticker in that range. The SMA indicator endpoint. Given a ticker, this calculates the simple moving average over any window you specify. We'll use 200 days. The grouped daily endpoint is the key to speed. Without it, you'd make one API call per stock. 12,000 calls, thousands of seconds. With it, you make one call and get everything back in under 2 seconds. Let's build it. Open a new Python file. We'll call it scanner.py. Standard imports, requests for HTTP, JSON, and OS for file handling. Time for rate limiting. The cache directory is important. We're going to save API responses locally so that on repeat runs every morning, we're not refetching data that hasn't changed. The 200-day moving average for a stock doesn't shift by more than a fraction of a percent overnight. We cache it once and reload it fast. Step 1. The grouped daily function. This is the entire market in one HTTP request. One call, not 12,000 calls. The endpoint returns a list of every ticker that traded on that date with its open, high, low, close, and volume. We extract the close price for each one and store it in a dictionary, ticker to price. The cash check at the top means that after the first time you run this on a given date, subsequent runs load from disk. Instant. When you run this for the first time on a given date, you see 12,358 tickers fetched, 1 API call. Every run after that, loaded from cache, instant. Step 2. The market cap filter. The reference ticker's endpoint accepts market cap filters directly. We pass market cap.gte for the minimum, greater than or equal, and market cap.lte for the maximum. Results come back paginated at 1000 per page, so we loop until there's no next underscore URL in the response. We return a Python set, not a list. Sets have constant time membership checks. When we intersect this universe with the 12,000 price tickers, it's fast, regardless of how many market cap tickers we have. Step 3. The 200-day MA check. 1 API call per ticker. We ask for the 200-day SMA on the daily time frame. Close price, limit 1. We only need the most recent value. If the current price is above it, the function returns true. If not, false. We cache the result per ticker. On the first run, this makes 1 API call per candidate. On subsequent runs, it loads from the cache file. That's what makes this fast every morning. The heavy lifting is done once. Now the main function. The main function chains the 3 steps. Get all prices for yesterday. Get the market cap universe. Intersect them to get candidates. Check each candidate against its 200-day MA. Return what qualifies. Run it. Step 1. Loading all market prices. 12,358 tickers fetched. 1 API call. Step 2. Applying market cap filter. 847 candidates. Step 3. Checking 200-day moving average, and then the tickers start printing. Each one that passes. Ticker, price, the first run takes a few minutes because it's building the cache, making individual SMA calls for hundreds of tickers. Every morning after that runs in under 60 seconds because the SMA data is cached and only the daily prices need a fresh fetch. What you end up with is a list of maybe 30 to 60 stocks, depending on market conditions, that meet both criteria, mid-cap, trend intact. That's your starting universe for the day. From there, you apply your technical filters. You look at charts, you look at setup quality, but you're not doing that for 12,000 stocks. You're doing it for 30. That's the leverage Python gives you. A few things to add in production. 1. The SMA cache should expire. Moving averages drift, not by much overnight. But if you use week-old cache values, they become stale. Add a timestamp to the cache file and refetch if it's older than 1 trading day. 2. Add a minimum dollar volume filter. Some mid-cap stocks are thinly traded. A stock with $500,000 of daily volume is hard to enter and exit cleanly. Add volume times close price as an additional filter. Filter out anything below, say, 5 million in daily dollar volume. 3. Log the results. Write the output to a CSV with the date, ticker, price, and 200-day SMA value. After a few months, you have data to backtest whether this starting universe actually produces good setups. Those are the production improvements. The core scanner you've built today already does the heavy lifting. This is episode 51, the first video in the Python series. The next episode is about backtesting, and specifically why most backtests are lying to you. There are 4 ways a strategy can look profitable in testing and fail in live trading. Look ahead bias, survivorship bias, overfitting slippage. We'll build a backtest from scratch and demonstrate all 4 traps with real code. Subscribe if you want that one. See you Thursday.